Now, in this lecture, we'll answer on two questions. In the first question, we'll find out the radius of this quarter circle. In the second question, we'll find out the size of this angle, angle theta, that is inside triangle ABC. So we start with the first question. In the drawing, we have a quarter circle. Line segment BC equals to 9 units. Line segment CD equals to 16 units. Line segment DL equals to 12 units. Angle OBC equals to 90 degrees. Angle BCD equals to 90 degrees. And this angle, angle CDL, is also equals to 90 degrees. And our mission is to find out the radius of this quarter circle. So, because of the fact that this is a quarter circle, point O must be the center of the quarter circle. So I write it down here that point O is the center of the quarter circle. And also point this angle, angle BOF, is equal to 90 degrees. And side AO equals to side OF, and both sides are the radii of this quarter circle. We'll define the radius of this quarter circle as R. So here AO equals to R, it is the radius of the quarter circle, and OF is also equals to R, it is also the radius of this quarter circle. In the next step, we will extend the straight line CD by straight line until it intersects with the radius OF. And we will define the touching point of the extended straight line CD and OF as point M. So by this construction, we created here quadrilateral BCOM. Okay, so here I write it down. We have here quadrilateral BCOM. And in quadrilateral BCOM, or inside quadrilateral BCOM, here inside this quadrilateral BCOM, we have 1, 2, 3 right angles. Repeat again, inside this quadrilateral we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we'll subtract 270 degrees from this equation, and we'll get that the missing angle, angle DMO, is equal to 360 degrees on 270 degrees, it is equal to 90 degrees. So the missing angle is the right angle, it is equal to 90 degrees. So this angle equals to 90 degrees. So we actually found out that inside quadrilateral BCOM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral BCOM as a rectangle. Okay? Why? Because it has 4 right angles. Okay? But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle BCOM, its opposite sides must be equal to each other. So side BC must be equal to side OM. Side BC must be equal to side OM. But it is given as the question that side BC equals to 9 units. So you can write here that BC equals to 9. And from this equation, 9 equals to BC equals to OM, we will derive that side OM is also equals to 9 units. OM equals to 9 units, so we can write here that side OM equals to 9 units. And here, it is given us the question that CD is a straight line. And we actually extended the straight line CD by a straight line. And the result is line segment CM. When you extend a straight line by a straight line, the result must be a straight line. So the result that is CM must be a straight line, so we write down that CM is a straight line. Repeat again, line segment CM is a straight line. And we also have here rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here CD is a straight line. So if we focus on the upper side of the straight line CD at point O, according to this rule number 3, the sum of the angles here must be equal to 180 degrees. So which angles we have at the upper side of CD at point O? We have here angle alpha plus beta. So alpha plus beta must be equal to 180 degrees according to this rule number 3. So we actually can implement rule number 3 in our drawing, because in our drawing we have the straight line CM. So if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have at this side of the straight line CM at point D? We have here 90 degrees. This angle equals to 90 degrees. Plus this angle that is actually angle LDN. So in total the sum of those two angles must be equal to 180 degrees. Repeat again. At one side of the straight line CM at point D, the sum of the angles must be equal to 180 degrees, that is to say 90 degrees plus the size of angle LDM. In total it must be equal to 180 degrees. Here we will subtract 90 degrees from this equation and we will find out that the missing angle LDM is equal to 180 degrees minus 20 degrees. It is equal to 90 degrees. Okay, so actually found out that this angle, it is a right angle, it is equal to 90 degrees. Likewise, OF is the radius of the quarter circle, therefore it is absolutely a straight line. So we can write down that OF is a straight line. OF is a straight line. So radius of the quarter second, it must be a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of OF at point M? We have here this angle that is equal to 90 degrees plus this angle that is actually angle DMF. So 90 degrees plus the size of this angle, angle DMF, in total they must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay. Repeat again. At the upper side of the straight line OF at point M, the sum of the angles must be equal to 180 degrees. So 90 degrees plus DMF must be equal to 180 degrees. We will subtract 90 degrees from this equation and we get that the missing angle, angle DMF, equals to 180 degrees minus 90 degrees. It is 90 degrees. So I found out that the missing angle, angle DMF is a right angle. It is equal to 90 degrees. So this angle equals to 90 degrees. In the next step, we'll do a construction from point L. We'll draw perpendicular on OF. I'll repeat again. From point L, we'll draw perpendicular on the radius OF. Okay. So here, this angle equals to 90 degrees according to our construction, and we will define the touching point of the perpendicular from point L and OF as point N. Actually, by doing this construction, we created the quadrilateral LDMN. Okay, we created the quadrilateral LDMN. And inside quadrilateral LDMN, we have 1, 2, 3 right angles. So I repeat again, inside quadrilateral LDMN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle DLN. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here, this equation expresses the fact that the sum of the angles in quadrilateral LDMN equals to 360 degrees. Here we will subtract 270 degrees from this equation, and we get that the missing angle, angle DLN, is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees, that is to say it is a right angle. So this angle, it is a right angle that is equal to 90 degrees. Okay. So we actually found out that inside quadrilateral DLMN we have 4 right angles. and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So quadrilateral, so we relate to quadrilateral DLMN as a rectangle. I repeat again. Quadrilateral DLMN is a rectangle. Why? Because it has 4 right angles. We will define side DM as edge. Here side DM equals to edge according to our definition. So in rectangle DLMN, the opposite sides are equal to each other. That is to say, side DM must be equal to side NN. Repeat again, side DM must be equal to side NN in rectangle DLMN. DM, this side is side DM, must be equal to side LN according to the rule that the opposite sides of a rectangle are equal to each other. Okay, side DM equals to side LN. But according to our definition, side DM equals to edge. So if you write down that DM equals to edge, and from this equation DM equals to LN equals to edge, we will derive the side DM is also the side here, according to our definition, side DM equals to edge, and from this equation edge equals to DM equals to LN. Here edge equals to DM equals to LN. We will derive that side LN is also equals to edge. Side LN is also equals to edge. Okay. Here, side LN is also equals to edge. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we'll get that in rectangle DLMN, side DL must be equal to side MN. I'll repeat again, in rectangle DLMN, side DL must be equal to side MN. But according to what is given us in the question, side DL equals to 12 units. Here, so we can write down that DL equals to 12. And from this equation, 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Okay, side MN is also equals to 12 units. So actually, line segment ON, or here this line segment ON equals to 9 plus 12, that is 21. And because of the fact that points N and F are very close to each other, so we are expecting to get a radius, or F is the radius of this quarter circle, the radius that we are looking for. We are expecting that the radius of the quarter circle will be a little bit longer than 21 units, but that is the length of line segment ON. Why? Because points N and F are very close to each other. In the next step, we will join points O and C together by a straight line. So here, point O is the radius of the quarter circle. Point C is the point of the quarter circle itself. So this is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to R according to our definition. In the next step, we will prove that the green right triangle, triangle COM, we will implement the Pythagoras theorem on the green right triangle triangle COM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay. Here, by PT is the relation for Pythagoras theorem. The hypotenuse of the right triangle OCM, the right triangle OCM is OC, therefore the square of the hypotenuse is OC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OM squared plus CM squared. Repeat again, according to the Pythagoras theorem, in the right triangle COM, OC square must be equal to OM square plus CM square. So here, OC equals to R, it is the radius of the quarter circle, therefore OC square equals to R square, and it is equal to ON square. OM square. OM equals to 9, therefore OM square is 9 squared, that is 81, plus CM square. What is the length of CM? CM equals to CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is H. In total, CM equals to 16 plus H. So if CM equals to 16 plus H, then CM square equals to 16 plus H square. So in conclusion, we found out that according to equation number 1, R square equals to 81 plus 16 plus H square. Here we open the brackets on this side of equation number 1, and we get that according to equation number 1, R square equals to 81 plus 16 plus H square equals to 16 square, that is 256 plus H square plus 2 times 16 is 32, and 2 times H is 32H. So in conclusion, we found out that according to equation number 1, R square equals to 81 plus 256 plus H square plus 32H. 81 plus 256 is 337. So we got that according to equation number 1, R square equals to 81 plus 256 is 337 plus H square plus 32H. Repeat again, according to equation number 1, we found out that R square equals to 337 plus H square plus 32H. In the next step, we will join points O and L together by a straight line. Here, point O is the center of the quarter circle. Point L is the point on the quarter circle itself. This is exactly the definition of a radius. That is to say, OL is the radius of this quarter circle, that is equal to R. In the next step, we will implement the Pythagoras theorem on the right orange triangle LNO. according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse is LO, therefore the square of the hypotenuse is LO squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to LF squared plus ON squared. I'll repeat again. In the orange right triangle, triangle LNO, according to the Pythagoras theorem, LO square must be equal to LF square plus NO square plus ON square. Okay. LO is the radius of the quarter circle, that is equal to R, therefore LO square is R square, that is equal to LF square. Here LF equals to H, therefore LF square is H square plus ON square. Here ON equals to 9 plus 12, that is 21, therefore ON square equals to 21 square. So according to equation number 2, we found out that R square equals to H square plus 21 square. 21 square equals to 441, therefore I will write it down here, that we get that according to equation number 2, R square equals to H square plus 441. So here you actually have two different expressions for R square. Therefore we create the equation number 3 that states that R square, according to equation number 1, must be equal to R square according to equation number 2. And R square, according to equation number 1, is equal to 337 plus H square, and it must be equal to R square according to equation number 2, that is actually equals to H square plus 441. So here we have H square on both sides of equation number 1, so H square will get cancelled. What is there from equation number 3? This is equation number 3, of course. What is left from equation number 3 after we cancelled H square? In this side of the equation we have 300, yeah, it's actually R square according to equation number 1 equals to 337 plus H square plus 32H. So in this side of the equation we have 32H plus 337. In the other side of the equation we have 441. Here we subtract 337 for this equation, equation number 3, and we get that according to equation number 3, 32H equals to 441 minus 337 is 104. So in conclusion, we found out that according to equation number 3, 32H equals to 104. Here we'll divide this equation number 3 by 32, and we get that h equals to 104 over 32. 104 over 32 is 3.25 units. So in conclusion, we found out that h equals to 3.25 units. In the next step, we will substitute h by 3.25 in equation number 2. According to equation number 2, r squared equals to h squared plus 441. So according to equation number 2, r squared equals to h squared. H equals to 3.25, therefore h squared is 3.25 squared, that is 10.5625 plus 441. So according to equation number 2, r squared equals to 10.5625 plus 444, that is 451.5625. Here we take out of this equation number 2, and we get that the radius that we are looking for of the quarter circle is equal to the square root of 451.5625. This is actually equals to 21.25 units. Okay, so I actually found out that the radius of this quarter circle r equals to 21.25 units. This is actually a little bit longer than line segment ON, that is equal to 21 units. Therefore, it is actually longer than line segment ON in 0.25 units. Okay. So we finished with the first question. In the next step, I will present to you the second question, and we'll solve the second question in 2 different methods. So in the drawing, we have triangle ABC, side AB equals to x plus y units, side AC equals to y units, side DC equals to x units, angle ACB equals to 40 degrees, angle ADC equals to 80 degrees, and we are looking for this angle theta, that is actually also equals to angle ABC. Okay, so in the first method, we start with the first method. In the first method, we will do a construction. We will extend side BC in y units. That is to say, here we define this point E. So here the length of line CE, the length of line segment CE equals to y units according to our construction. In the next step, we'll join points A and E together by a straight line. So here we created triangle ACE. I will copy triangle ACE in a new page, and we will analyze triangle ACE. So this is triangle ACE that I copied from the original drawing. In triangle ACE, AC equals to Y according to what is given as the equation, and C equals to Y according to our construction. So those two sides, they are both equal to Y, therefore they are equal to each other. So I write it down. AC equals to CE equals to Y. They are both equal to Y, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of this side we have angle CAE. And in front of this side we have angle CEA. And according to the rule that I mentioned, those two angles must be equal to each other because they are located in front of equal sides. So angle CAE must be equal to angle CEA. So if we define angle CAE here, this angle as alpha, then from this equation alpha equals to angle CAE equals to angle CEA, we will derive that angle CEA is also equals to alpha. And this angle equals to alpha. Okay. In the next step I will copy angle AD, angle ACB, this angle in our here. This angle equals to 40 degrees according to what is given as the question. So this is actually angle ACB that I copied from the original drawing, that is equal to 40 degrees according to what is given as the question. So I'll present to you the angle bisector and the exterior angle theorem. What is the exterior angle theorem? The exterior angle theorem is true in any triangle so here we have triangle ABC that could be any triangle. This is triangle ABC. Angle ABC equals to alpha, angle BAC equals to beta, and angle ACB equals to gamma. So those three angles, alpha, beta, and gamma, are defined as an interior angles. Why? Because they are located inside triangle ABC. Therefore, they are defined as an interior angles. Okay, while this angle ACD, this angle is defined as an exterior angle. Why? Because it is located outside triangle ABC. So we define angle ACD as E. Here angle ACD is equal to E according to our definition, and this is the exterior angle of this triangle, triangle ABC. Okay. So what is the size of the exterior angle, angle E? The size of the exterior angle, angle E is equal to the sum of the two interior angles that are not adjacent to it. Here, this angle, angle Y, is adjacent to angle E, and the two other interior angles that are not adjacent to angle E are alpha and beta. And the sum of those two angles is alpha plus beta. So in conclusion, we found out that the size of the exterior angle E equals to alpha plus beta according to the angle exterior theorem. I'll repeat again. The size of the exterior angle E equals to the sum of the two interior angles that are not adjacent to it. And the two interior angles that are not adjacent to it are alpha and beta, therefore angle E equals to in its size to alpha plus beta. So, okay, this is the exterior angle theorem. Now we will implement the exterior angle theorem in this triangle, triangle ACE. Here, those two angles are defined as an exterior angle, so those two angles alpha and alpha are defined as interior angles. Of triangle ACE, while this angle ACB, this angle is defined as an exterior angle. So what is the size of the exterior angle ACB? The size of the exterior angle ACB, it is equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to angle ACB, while those two angles are not adjacent to it. Those angles are alpha and alpha. The sum of those two angles is alpha plus alpha. So the size of the exterior angle ACB will be equal to alpha plus alpha, that is 2 alpha, according to the angle bisector theorem. And here it is given us the question that angle ACB equals to 40 degrees in its size. So from this long equation, 40 degrees equals to ACB equals to alpha plus alpha equals to 2 alpha, we will derive that 40 degrees equals to 2 alpha. Here we'll divide this equation by 2, and we'll get that alpha equals to 40 degrees over 2 is 20 degrees. So I found out that this angle alpha equals to 20 degrees, and this angle that is also angle alpha, it is also equals to 20 degrees. So we write it down in the original drawing. Angle CAE, this angle is angle alpha that is equal to 20 degrees, and angle CEA is this angle that is also angle alpha that is equal to 20 degrees. We'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees, so the sum of those two angles is 120 degrees. Therefore, the third angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC to 180 degrees. This angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in triangle ADC and the sum of the angles in any triangle. So this angle equals to 60 degrees. In the next step, I will copy the triangle ADE, and in the new page we'll analyze triangle ADE. Okay. Angle DAC, this angle equals to 60 degrees plus 20 degrees, that is 80 degrees. And this angle equals to 80 degrees according to what is given as a question. And what is the size of side DE? Here DE equals to DC plus CE. Again, DE equals to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. In conclusion, DC equals to X plus Y. So this is triangle ADE that I copied from the original drawing. And here in triangle ADE, those two angles are equal to each other, and we know that in front of equal angles in the triangle there are equal sides. Okay, so here in front of this angle we have side DE, while in front of this angle we have side AE. And according to the rule that I mentioned, those two sides must be equal to each other. Why? Because they are located in front of equal angles. Okay? So D equals to A. But according to what we already found out, that D equals to x plus y. So we can write here that D equals to x plus y. And from this equation, x plus y equals to D equals to AE, we will derive that AE is also equals to x plus y. AE equals to x plus y. In the next step, I will copy the triangle ABAE in this page and we will analyze triangle ABE. So this is triangle ABE, the big triangle. Side AB equals to x plus y, according to what is given us the question. Angle ABC equals to theta, according to what is given us the question. That is the angle that we are looking for. Angle AEB equals to 20 degrees, according to what we have already found out. And here we just right now found out that side AE equals to x plus y. Side AE equals to x plus y. So those two sides are both equal to x plus y, therefore they are equal to each other. So side AB equals to side AE. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of this side, side AE, we have angle theta, and in front of this side, side AB, we have angle, this angle that is equal to 20 degrees. So those two angles are located in front of equal sides. Here side AB equals to side AE. They are located in front of equal sides, and therefore they are also equal to each other. That is to say, angle theta equals to 20 degrees. So I found out that the angle that we are looking for, angle theta, is equal to 20 degrees in its size. Okay, this angle equals to 20 degrees in its size. We finished with the first method. In the next step, I will present to you the second method. Okay. In the second method, we will focus on triangle ADC. This angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So the sum of the angles of the two angles in triangle ADC is 120 degrees. Therefore, the third angle, angle DAC, must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is 180 degrees, and this is the sum of the angles in triangle ADC and also in any triangle. Okay, in the next step we will define side AD as A. I will present to you the law of sines, and we will implement the law of sines in this triangle, triangle ADC, and we will also implement the same law in triangle ABD. So what is the law of sines? The law of sines is for in any triangle. So here we have the law of sines. So here we have triangle ABC that could be any triangle. This is triangle ABC. Side BC of triangle ABC equals to A units in its length. Angle BAC, this triangle ABC equals to A degrees, capital A degrees in its size. Side AC equals to B units in its length. And angle ABC equals to B degrees in its size. And here side AB equals to C units in its length, and angle ACB equals to capital C degrees in its size. Okay, so here according to the law of sines, we will get that A over sine A is equal to B over sine B, and it is also equal to C over sine C. Okay, and this equation is true in any triangle. And repeat again, A over sine A equals to B over sine B equals to C over sine C. Now we will implement this law, the law of sines, in the green triangle, triangle ADC. Okay, here triangle ADC, we implement the law of sines. So actually, in the green triangle, triangle ADC, according to the law of sines, we'll get that AC over sinus 80 degrees equals to AD over sinus 40 degrees, and it is equal to DC over sinus 60 degrees. I'll repeat again. We implemented the law of sines in the green triangle, triangle ADC. According to the law of sines, AC over sinus 80 degrees equals to AD over sinus 40 degrees equals to DC over sinus 60 degrees. Here AC equals to Y, so we substitute AC by Y, and we get that according to equation number 1, Y over sinus 80 degrees equals to AD equals to A according to our definition, so we substitute AD by A over sinus 40 degrees that is equal to DC. DC equals to X, so we substitute DC by X, so it is X over sinus 60 degrees. So according to equation number 1, we found out that Y over sinus 80 degrees equals to A over sinus 40 degrees, and it is equal to X over sinus 60 degrees. So we have here three different expressions that are all equal to each other, so we can define the value of each other as k. So here all the three expressions are equal to k according to our definition, and we'll create the first equation, we'll derive the first equation with this long equation. This expression is equal to k. So this will be equation number 1, that y over sinus 80 degrees is equal to k. We'll multiply this equation number 1 by sinus 80 degrees, and we'll get that according to equation number 1, y equals to k times sinus 80 degrees. So this is the first equation, the expression for y. In the next step, we create the second equation from this long equation. Those two expressions are also equal to each other. That is to say, a over sinus 40 degrees, it is equal to k. Here we multiply this equation number 2 by sinus 40 degrees, and we will get that according to equation number 2, a equals to k times sinus 40 degrees. So we have the expressions for a also. A equals to k times 40 degrees. And finally, those two expressions are also equal to each other. Okay, so we can write down that here that x over sinus 60 degrees is equal to k. Here we will multiply this equation number 3 by sinus 60 degrees, and we'll get that according to equation number 3, x equals to k times sinus 60 degrees. So here we have the three expressions for a, x and y. Here we know that ABC is a triangle, and therefore side BC is one side of triangle ABC, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this angle that is equal to 90 degrees plus this angle. And the sum of those two angles must be equal to 180 degrees. So if this angle equals to 80 degrees, this angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of the straight line BC at point D to 180 degrees. This angle must be equal to 100 degrees, because 100 degrees plus 80 degrees will be equal to 180 degrees. So in the next step we will implement the law of sines in the orange triangle, triangle ABD. So in the orange triangle, triangle ABD, according to the law of sines, we get that AD over sinus theta equals to AB over sinus 100 degrees. I'll repeat again, in the orange triangle ABD, according to the law of sines, AD over sinus theta equals to AB over sinus 100 degrees. Here, AD equals to A, so we substitute AD by A, and we get that A over sinus theta equals to AB. AB equals to x plus y, therefore we substitute AB by x plus y over sinus 100 degrees. So we actually found out that according to equation number 2, A over sinus theta equals to x plus y over sinus 100 degrees. In the next step, we will substitute A, x, and y by the values that we found for them. Okay, here we found out that x equals to k times sinus theta, therefore we substitute x by k times sinus theta, by k times sinus 60 degrees. And we have already found out that y equals to k times sinus 80 degrees, so we substitute y by k times sinus 80 degrees. And we also found out that A equals to k times sinus theta, therefore we substitute A by k times sinus 40 degrees. A equals to k times sinus 40 degrees, therefore we substitute A by k times sinus 40 degrees. So here we substitute A by k times sinus 40 degrees, we substitute x by k times sinus 60 degrees, and we substitute y by k times sinus 80 degrees. We got this expression. Here we have k on both sides of equation number 2, so k will get cancelled. What is left from equation number 2 after we cancelled k? What is left is actually we have here sinus 40 degrees over sinus theta is equal to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Okay, here we cross multiply this equation number 2, and we get that according to equation number 2, sinus 40 degrees times sinus 100 degrees is equal to sinus theta times sinus 80 degrees plus sinus 60 degrees. Okay. Here we will divide this equation number 2 by sinus 80 degrees plus sinus 60 degrees, and we get that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Okay. So in the next step I will present to you the first trigonometric identity. The first trigonometric identity is sinus 2a. It is equal to 2 times sinus a times cosine a. Okay, we'll use this trigonometric identity for sinus 40 degrees. That is in equation number 2. Here sinus 40 degrees is equal to sinus 2 times 20 degrees, and according to this trigonometric identity, the sinus 2a equals to 2 sine a cosine a. We get that sinus 2 times 20 degrees is equal to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that according to this trigonometric identity, sinus 40 degrees is equal to 2 times sinus 20 degrees times cosine 20 degrees. Okay. Actually, we'll substitute sinus 40 degrees, but by 2 times sinus 20 degrees cosine 20 degrees. But before we do it, I'll present to you the second trigonometric identity, that sinus 90 degrees plus theta is equals to cosine theta. We'll use this trigonometric identity for sinus 100 degrees, that is in equation number 2. So here sinus 100 degrees equals to sinus 90 degrees plus 10 degrees, and sinus 90 degrees plus 10 degrees, according to the trigonometric identity that sinus 90 degrees plus theta equals to cosine theta, we get that sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees it is equal to cosine 10 degrees. Okay, therefore we substitute sinus 100 degrees by cosine 10 degrees in equation number 2, and we also substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees in the same equation, equation number 2. And we get that according to equation number 2, sinus theta is equal to sinus 40 degrees. Sinus 40 degrees, according to what we just right now found out, that it is equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay, so we substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees in equation number 2, and we have to multiply it by sinus 100 degrees, but we substitute sinus 100 degrees by cosine 10 degrees. Okay, and we have to divide all by sinus 80 degrees plus sinus 60 degrees. Okay, We have another trigonometric identity for sinus 80 degrees plus sinus 60 degrees. According to the following trigonometric identity, sinus D plus sinus C is equals to 2 times sinus D plus C over 2 times cosine D minus C over 2. We'll use this trigonometric identity to find out the value of sinus 80 degrees plus sinus 60 degrees. Okay, so the value of sinus 80 degrees plus sinus 60 degrees according to this trigonometric identity will be equal to 2 times sinus D plus C. D is 80, C is 60, so 80 plus 60 is 140, and 140 over 2 is 70. And we have to multiply it by cosine D minus C over 2. D is 80, C is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees is equal to 2 times sinus 70 degrees times cosine 10 degrees. So we substitute sinus 80 degrees plus sinus 60 degrees by 2 times sin 70 degrees times cosine 10 degrees in equation number 2. And we get that according to equation number 2, sinus theta is equal to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees divided by sinus 80 degrees plus sinus 60 degrees, but we just right now found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. We substituted sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. We have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So what is left from equation number 2 after we cancel the two expressions? What is left is actually we have here according to equation number 2, we found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. In the next step, I'll present to you the last trigonometric identity. This is actually here sinus 90 degrees minus theta. It is equal to cosine theta. We use this trigonometric identity for sinus 70 degrees. We have here sinus 70 degrees. It is equal to sinus 90 degrees minus 20 degrees, and sinus 90 degrees minus 20 degrees, according to the trigonometric identity, the sinus 90 degrees minus theta equals to cosine theta, so sinus 90 degrees minus 20 degrees will be equal to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees is equal to cosine 20 degrees. Now we'll substitute sinus 70 degrees by cosine 20 degrees in this equation number 2. And we get that according to equation number 2, sinus theta is equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, and we substitute cosine 70 degrees by, we substitute sine 70 degrees by cosine 20 degrees in this equation number 2, and we get Here we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and we left only, according to equation number 2, sinus theta equals to sinus 20 degrees. And we know we have the trigonometric identity that if sinus alpha equals to sinus beta, then alpha equals to beta. Therefore, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So we found out that theta equals to 20 degrees according to the second method also. So we finish with the second method. In the next step, I present to you, in the next step, we summarize the lecture. We'll start with the first question, of course. In the drawing, we have a quarter circle, 9 segment BC equals to 9 units, 9 segment CD equals to 16 units, 9 segment DL equals to 12 units, angle OBC equals to 90 degrees, angle BCD equals to 90 degrees, and angle CDL equals also to 90 degrees, and our mission is to find out the radius of this quarter circle. So first of all, because of the fact that this is a quarter circle, you can derive from it that this point O is the center of the quarter circle. This angle equals to 90 degrees, and that side AO equals to side OF, and they are both the radii of this quarter circle. We define the radius of this quarter circle as R, therefore AO equals to R, and OF is also equals to R. They are both the radii of the quarter circle. Okay? In the next step, we actually did a construction. We extended the straight line CD by a straight line until it intersects with side OF. That is the radius of the quarter circle. And we define the touching point of the extended straight line CD and OF is point M. By doing this construction, we created a quadrilateral BCOM. So inside this quadrilateral BCOM, we have 1, 2, 3 right angles. Again, inside quadrilateral BCOM, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation. We found out that the missing angle DMO, it is equal to 360 degrees from 270 degrees, it is equal to 90 degrees. So this angle, it is right angle, it is equal to 90 degrees. So we actually found out that inside quadrilateral BCOM, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate quadrilateral BCOM as a rectangle. Okay, and we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle BCOM, they are equal to each other. That is to say, side BC equals to OM. So BC equals to OM. But according to what is given as the question, side BC equals to 9 units. So we can write here that BC equals to 9. And from this equation, 9 equals to BC equals to OM, we will derive that OM is also equals to 9 units. Here, side OM equals to 9 units. Then we actually know that CD is a straight line. It is given as the question. And when we extended the straight line CD by straight line, the result is CM. And when you extend the straight line by straight line, the result must be a straight line. So the result that is CM must be a straight line. So we can write here that CM is a straight line, and we have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on the upper side, on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have here? We have this angle that is equal to 90 degrees plus this angle that is angle MDL. So here 90 degrees plus angle MDM, in total they must be equal to 180 degrees according to rule number 3. We subtracted 90 degrees from this equation and found out that the missing angle LDM equals to 90 degrees. So this angle LDM equals to 90 degrees, it is a right angle. Likewise, OF is the radius of the quarter circle, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. So here, in the upper side of OF at point M, the sum of the angles must be equal to 180 degrees, that is to say 90 degrees plus the size of this angle, that is actually angle DMF. In total, the sum of those two angles must be equal to 180 degrees. Here we subtracted 90 degrees from this equation and found out that the missing angle DMF is equal to 180 degrees minus 90 degrees, it is equal to 90 degrees. So I found out that this angle is also equal to 90 degrees. Then we did the construction. From point L, we drew perpendicular on the radius OF. I repeat again, from point L, we draw perpendicular on the radius OF. So this angle equals to 90 degrees according to our construction. So by doing this construction, we created here quadrilateral LDMN. In quadrilateral LDMN, we have 1, 2, 3 right angles. And the sum of right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle DLN. In total, the sum of those four angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here, inside quadrilateral DLMN, the sum of the angles must be equal to 360 degrees. That is to say 270 degrees plus the size of the fourth angle DLN, they must be equal in total to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle DLN equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So here the missing angle DLN equals to 90 degrees. So we actually found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral DLMN as a rectangle. Quadrilateral DLMN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. Here we define side DM as edge. So in rectangle DLMN, side DM, this side must be equal to side LN. Side DM must be equal to side LN. And according to our definition, DM equals to H. So here from this equation, H equals to DM equals to LN, we will derive that side LN is also equals to H. Here side LN is also equals to H. Okay? Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, so in rectangle DLMN, side DL must be equal to side MN. Side DL must be equal to side MN, but it is given as the question that side DL equals to 12 units. Here, side DL equals to 12 units. So from this equation, 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Here, side MN is also equals to 12 units. In the next step, we join point C and O together with a straight line. Point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to R. Then we implemented the law the Pythagoras theorem on the green triangle, the green right triangle, triangle COM. In the green right triangle, triangle COM, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, OC square equals to OM square plus OM. OC square equals to OCM square plus OM square. Again, OC square or CO square equals to CM square plus OM square. Repeat again. According to the Pythagoras theorem, in the right green triangle, triangle CMO, OC square equals to OM square plus CM square. OC is the radius of the quarter circle that is equal to R, therefore OC square is R square. OM equals to 9, therefore OM square is 9 square, that is 81, plus CM square. CM equals to 16 plus H, therefore CM square equals to 16 plus H square. Here we open the brackets on this side of equation number 1 and we found out that R square equals to 81 plus 16 plus H square. 16 plus H square equals to 16 square, that is 256 plus H square plus 2 times 16 is 32 and 32 times H is 32H. So here 81 plus 256 is 337. So in conclusion, we found out that according to equation number 1, R square equals to 337 plus H square plus 32H. Okay, then we join points O and F together by a straight line. Here point O is the center of the quarter circle. Point L is the point of the quarter circle itself. Therefore OL is the radius of the quarter circle that is equal to R. Then we implemented the Pythagoras theorem on the orange right triangle, triangle OLN. According to the Pythagoras theorem, OL square equals to LN square plus NO square. Repeat again, in the right orange triangle, triangle NO, LNO, LO square equals to L, again, OL square equals to LN square plus ON square. Actually, LN square in the orange triangle, orange right triangle, triangle LNO, LO square equals to LN square plus ON square. LO equals to R, therefore LO square is R square. LN equals to H, therefore here LN equals to H. Here LN equals to H, therefore LN square equals to H square. And NO equals to 9 plus 12, that is 21. Therefore NO square will be equal to 21 square. So according to equation number 2, we found out that R square equals to H square plus 21 square. 21 square is 441, so in conclusion we found out that according to equation number 2, R square equals to H square plus 441. So we have two different expressions for R square. Therefore we can create equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. R square according to equation number 1 is equal to R square according to equation number 1 equals to 337 plus H square plus 32H, and it must be equal to R square according to equation number 2 that is equal to H square plus 441. Here we have H square on both sides of the equation, so H square will get cancelled, and we left what is left from equation number 3 after we cancelled H square. What is left in this side of the equation, we have 32H plus 337 that is equal to 441. Here we subtracted 337 from this equation, equation number 3, and found out that according to equation number 3, 32H equals to 441 minus 337 is equal to 104. Therefore, we found out that according to equation number 3, 32H equals to 104. We divided this equation number 3 by 32. And finally, we found out that H equals to 104 over 32, that is 3.25. So we found out that H equals to 3.25 units. Then we substituted H square in equation number 2 by 3.25 square. Okay, because H equals to 3.25. So here according to equation number 2, R square equals to H square plus 441. So if h equals to 3.25, it means that s squared is 3.25 squared. So according to equation number 2, we found out that r squared equals to 10.5625 plus 441. 10.5625 plus 445 is 441.5625. So according to equation number 2, we found out that r squared equals to 451.5625. We took out of this equation number 2, and we found out that r equals to the square root of 451.5625, that is 21.25 units. In conclusion, we found out that the radius of this quarter circle it is equal to 21.25 units. That is to say, the radius of this quarter circle is bigger only by 0.25 from ON, because ON equals to 21 units in its length, while the radius of this quarter circle it is equal to 21.25 units. Okay, exactly according to our expectations, that the value of the radius of this quarter circle it is very close to the value of ON, that is 21. We finished with the first question, then I presented to you the second question. We solved the second question in two different methods. According to the first method, we have here triangle ABC. Side AB equals to x plus y units, side AC equals to y units, side DC equals to x units, angle ACB equals to 40 degrees, angle ADC equals to 80 degrees, and our mission is to find out the size of this angle theta, that is also equal to angle that is also can be defined as angle ABC. Okay, so in the first method we did the construction. We extended side BC by straight line. We extended side BC in y units. Okay, so that is to say CE equals to y units according to our construction. Then we joined together points A and E together by a straight line. This way we created triangle ACE, and then I copied triangle ACE in a new page and we analyzed triangle ACE. So this is triangle ACE that I copied from the original drawing. Side C equals to y units according to our construction. Side AC also equals to y units according to what is given as the question. Those two sides are both equal to y, therefore they are equal to each other. So side AC equals to side CE, and we have the rule that in front of equal sides in the triangle there are equal angles. So this side is located in front of this angle, this side is located in front of this angle, therefore those two angles that are located in front of equal sides must be equal to each other. That is to say, side CAE, angle ACAE must be equal to angle CEA. So if we define one angle as alpha, then the other angle must be also equal to alpha because of the fact that they are equal to each other. So those two angles are both equal to alpha. Then I copied angle ACB, this angle that is equal to 40 degrees according to what is given as the question. I copied it here. Angle ACB equals to 40 degrees according to what is given as the question, and then I presented to you the exterior angle theorem. The exterior angle theorem is true in any triangle. So here we have triangle ABC that could be any triangle. This angle equals to alpha, this angle equals to beta, and this angle equals to gamma. So those three angles, alpha, beta, and gamma, are defined as an interior angles because they are located inside triangle ABC. While this angle ACD, is defined as an exterior angle because it is outside triangle ABC. So this angle that is angle ACD that is equal to E according to our definition is defined as an exterior angle of triangle ABC. What is the side of the exterior angle E? According to the exterior angle theorem, the size of angle E it is equal to the sum of the two interior angles that are not adjacent to it. Here angle gamma is adjacent to angle E, and the two other angles that are not the two other interior angles that are not adjacent to it are alpha and beta, and the sum of those two angles alpha and beta are alpha plus beta. Therefore, the size of the exterior angle E it is equal to alpha plus beta. That is the sum of the two interior angles that are not adjacent to it. Then we implemented the exterior angle theorem in this triangle ACE. Those two angles are defined, alpha and alpha are defined as interior angles, and this angle ACB that is equal to 40 degrees is defined as an exterior angle. So the size of this angle ACB will be equal to the sum of the two interior angles that are not adjacent to it. This angle adjacent to this angle, the other two angles that are not adjacent, the other two interior angles that are not adjacent to angle ACB are those two angles, alpha and alpha. Therefore, the size of angle ACB will be equal to alpha plus alpha. Okay, angle ACB equals to alpha plus alpha according to the exterior angle theorem. Alpha plus alpha is 2 alpha. So we found out that angle ACB equals to 2 alpha from one side, but from the other side, angle ACB equals to 40 degrees according to what is given as the equation. So we can write down that angle ACB equals to 40 degrees, and from this long equation, 40 degrees equals to ACB equals to alpha plus alpha equals to 2 alpha. We will derive that 40 degrees equals to 2 alpha. We divided this equation by 2 and we found out that alpha equals to 40 degrees over 2, that is 20 degrees. So this angle equals to 40 degrees and this angle also equals to 40 degrees. We can write down in the drawing, in the original drawing, that angle AEC that is equal to alpha equals to 20 degrees, and this angle EAC that is also equal to alpha, it is equal to 20 degrees. Okay, and here in triangle ADC, so this angle equals to 60 degrees according to what we already found out. So what is the value of angle DAE? It is equal to 60 degrees plus 20 degrees, that is 80 degrees. So I copied triangle ADE in a new page and analyze triangle ADE. This is triangle ADE that I copied from the original drawing. This angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees. This angle equals to 80 degrees according to what is given as the question. And what is the size of angle the size of side DE? It is equal to DC plus CE. That is to say, DC equals to X plus CE, that is Y. So DE equals to DC, that is X, plus CE, that is Y. In total, this DE equals to X plus Y. So here DE equals to X plus Y, and those two angles are equal to each other, they are both equal to 80 degrees, therefore they are equal to each other. Okay, and we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of this angle, we have side AE. In front of this angle, we have side DE. And those two sides must be equal to each other. That is to say, DE must be equal to AE. Why? Because they are located, those two sides are located in front of equal angles. But we have already found out that DE equals to X plus Y. So we can write here that DE equals to X plus Y. And from this equation, X plus Y equals to DE equals to AE, we will derive that AE is also equals to X plus Y. Then I copied the big triangle ABE in this new page, and we analyze triangle ABE. AB equals to X plus Y according to what is given as the equation. A equals to X plus Y according to what we have already found out just right now. A equals to X plus Y. This angle equals to 20 degrees according to what we have already found out. And angle ABE, the angle that we are looking for, it is equal to theta according to what is given as the equation. So here, those two sides are both equal to X plus Y, therefore they are equal to each other. That is to say, side AB equals to side AE. And we have the rule that in front of equal sides in the triangle, there are equal angles. In front of this side AB, we have 20 degrees. in front of this side AE, we have angle theta. So according to the rule that I mentioned, here those two angles must be equal to each other because they are located in front of equal sides, in front of those two equal sides. Therefore, they must be also equal to each other. That is to say, angle theta equals to 20 degrees. So we finished with the first method, then I presented to you the second method. In the second method, we focused on triangle ADC. Triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So in triangle ADC, we have two angles that are equal to 120 degrees. So the third angle must be equal to 60 degrees because 60 degrees plus 120 degrees is 180 degrees. And the sum of the angles in any triangle must be equal to 180 degrees. Therefore, this angle must be equal to 60 degrees. Then we define side AD as A, and then I presented to you the law of sines, and we implemented the law of sines in the green triangle and then in the orange triangle. So what is the law of sines? The law of sines is true in any triangle. So this is triangle ABC that could be any triangle. Side AC equals to, side AB equals to C units, side AC equals to B units, side BC equals to A units, angle BAC equals to capital A degrees, angle ABC equals to capital B degrees in its size, angle ACB equals to capital C degrees in its size. So according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Then we implemented the law of sines in the green triangle, triangle ADC. According to the law of sines, we get that in triangle, the green triangle, triangle ADC, AC over sinus 80 degrees equals to AD over sinus 40 degrees, and it is equal to DC over sinus 60 degrees. So this equation number one is the implementation of the law of sines in the green triangle, triangle ADC. AC equals to Y, so we substitute AC by Y, AD equals to A, we substitute AD by A, DC equals to X, so we substitute DC by X. And then we have here three expressions that are all equal to each other. So we can define the value of each expression as X, xk. So I can say that the three expressions that are equal to each other, they are equal to K. Then we derived the first equation. Those two expressions are equal to each other, that is to say y over sinus 80 degrees equals to k. We multiplied this equation by equation number 1 by sinus 80 degrees and found out that y equals to k times sinus 80 degrees. We can also derive the second equation from this big equation, this long equation, that a over sinus 40 degrees also equals to k. So we multiplied the equation number 2 by sinus 40 degrees and found out that according to equation number 2, A equals to K times sinus 40 degrees. And finally, we derive the third equation from this long equation. Here those two expressions are also equal to each other. That is to say, x over sinus 60 degrees equals to K. So here x over sinus 60 degrees equals to K. We multiply this equation by sinus 60 degrees and we found out that x equals to K times sinus 60 degrees. So we have the expressions for A, X and Y. Then we found out the size of this angle. ABC is a triangle, therefore BC is one side of triangle ABC. So BC, it must be a straight line because it is a side of a triangle. So BC is a straight line, and if we focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of BC at point D? We have here 80 degrees. plus this angle, angle ADB. In total, the sum of those two angles must be equal to 80 degrees, to 180 degrees. So this angle equals to 80 degrees. Therefore, the other angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of the line BC to 180 degrees. This angle must be equal to 100 degrees because only 100 degrees plus 80 degrees will be equal to 180 degrees. Okay? So this angle equals to 100 degrees. Then we implemented the law of sines in the orange triangle, triangle ADB. So according to the law of sines, we'll get that AD over sinus theta equals to AB over sinus 100 degrees. I repeat again, in the orange triangle, triangle ADB, according to the law of sines, AD over sinus theta equals to AB over sinus 100 degrees. Here AD equals to A, so we substitute AD by A. AB equals to x plus y, so we substitute AB by x plus y. And we got that A over sinus theta equals to x plus y over sinus 100 degrees. Here we substituted A by k times sinus 40 degrees. We substituted x by k times sinus 60 degrees. And we substituted y by k times sinus 80 degrees. And we have only found out for a, x, and y. And we got this expression k times sinus 40 degrees over sinus theta equals to k times sinus 60 degrees plus k times sinus 80 degrees over sinus 100 degrees. Because we have k on both sides of the equation, so k will get cancelled. Then we cross multiply this equation. So after we cancel k, we have this expression that sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation number 2, and we found out that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 80 degrees plus sinus 60 degrees. Here we divided this equation number 2 by sinus 80 degrees plus sinus 60 degrees and found out that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Then I presented to you the first trigonometric identity, that sinus 2a equals to 2 sine a cosine a. We use this trigonometric identity for sinus 40 degrees, that is in equation number 2. Sinus 30 degrees equals to sinus 2 times 20 degrees. And sinus 2 times 20 degrees, according to this trigonometric identity, that sinus 2a equals to 2 sine a cosine a, will be equal to 2 times sinus 20 degrees times cosine 20 degrees. So, in conclusion, found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. We'll substitute sinus 20 degrees by 2 times sinus 20 degrees times cosine 20 degrees, but before we will do it, I presented to you the second trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta. We use this trigonometric identity for sinus 100 degrees. Sinus 100 degrees equals to sinus 90 degrees plus 10 degrees, and according to this trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta, we will derive from it that sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees, and sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Therefore, we can substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees in equation number 2. So we did it, we got that sinus theta, and we substituted sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees, and we have to multiply it by cosine by sinus 100 degrees, but we already found out that sinus 100 degrees equals to cosine 10 degrees. Therefore, we substituted sinus 100 degrees in equation number 2 by cosine 10 degrees. Okay, and we have to divide all by sinus 80 degrees plus sinus 60 degrees. Okay, then I presented to you another trigonometric identity, that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. We use this trigonometric identity for the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees will be equal to 2 times sinus D plus C. D is 80, C is 60, so 80 plus 60 is 140, and 140 over 2 is 70. So it is 70 degrees times cosine D minus C over 2. D is 80, C is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times sinus times cosine 10 degrees. So we can substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. We did it, and we found out that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees, and we substituted sinus 60 degrees plus sinus 80 degrees by 2 times sinus 70 degrees times cosine 10 degrees. Here we have cosine 10 degrees in the numerator, and we have cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator, we have 2 in the denominator, so 2 will also get cancelled. And finally we left only with, according to equation number 2, we found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Then I presented to you the last trigonometric identity, that sinus 90 degrees minus theta equals to cosine theta. We use this trigonometric identity for sinus 70 degrees. Sinus 70 degrees equals to sinus 90 degrees minus 20 degrees. And sinus 90 degrees minus 20 degrees, according to the trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, therefore sinus 90 degrees minus 20 degrees according to this trigonometric identity will be equal to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees, therefore we can substitute sinus 70 degrees by cosine 20 degrees in this equation, equation number 2. And so we did it, we got that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. But we already found out that sinus 70 degrees is equal to cosine 20 degrees, therefore we substituted sinus 70 degrees by cosine 20 degrees in this equation, equation number 2, and we found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over cosine 20 degrees. So we have cosine 20 degrees in the numerator, and we have cosine 20 degrees in the denominator, of course, so cosine 20 degrees will get cancelled. And finally we found out that sinus theta equals to sinus 20 degrees. And we have the trigonometric identity that if sinus alpha equals to sinus beta, it means that alpha equals to beta. So here, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So finally, in conclusion, we found out that in both methods, the size of this angle theta, it is equal to 20 degrees in its size, okay? Thank you very much.